In flexible programming languages, you can often throw any data into any variable. C and C++ operate differently. Look at this visual representation of computer memory. Before you can store anything, you have to create a specific container. Here, an integer block drops into a box labeled int using the equals operator. You are required to define the exact label and shape for every piece of data. The three foundational shapes you will use are int for whole numbers, float for decimals, and char for single characters. When you declare one of these types, you dictate exactly what that memory slot will accept. If you try to force a decimal into an int box or a character into a float box, the compiler will reject it. Once your data is in the container, you have to close it. Typing a semicolon at the end of your declaration acts as a mandatory command. It tells the compiler that your instruction is complete, locking that memory box shut and preparing the system for the next line of code. This strictness serves a specific technical purpose. By defining every memory boundary before the program starts, you're removing the need for the computer to check data types during execution. Eliminating those mid-run checks is a primary reason why C and C++ programs operate with high performance. Naming these variables comes with its own set of rigid rules. You cannot use spaces. You cannot start a variable name with a number. As you can see on this checklist, num_1 passes verification, while first_num fails immediately. Once your variables are properly named and declared, you can manipulate them using basic arithmetic operators: addition, subtraction, multiplication, and division. Look at this formula calculating the area of a rectangle. We are multiplying the length variable by the width variable. Notice the order of operations around the equal sign. In C and C++, the right side of the equation is completely evaluated first. The program calculates the result of length times width, creating a single integer, and only then is that result pushed across the equal sign into the area variable on the left. It is vital to understand that a single equal sign does not state a mathematical truth. It is an action. It represents a unidirectional movement of data from right to left. Forgetting this distinction is a frequent source of logic errors when programs get more complex. As your code grows, your program will need to make instant decisions based on the data held in these variables. Writing out full if-else code blocks for every minor decision takes up unnecessary space and slows down your workflow. To solve this, the industry standard is the conditional or ternary operator. This diagram breaks down the syntax. It evaluates a condition in parentheses. The question mark asks if the condition is true. If it is, the code executes the true result. The colon acts as otherwise, directing the code to the false result. Let's walk through a threshold comparison. The program checks if our number is greater than 14. If the condition is met, it executes the true path and prints greater. It completely ignores the code sitting after the colon. Now it's your turn to write this out. Pause the video. Declare a length integer as 10 and a width integer as 5. Calculate their area. Then use a ternary operator to print the word big if the area is over 40 and small if it is not. Give it a try. Mastering this syntax is a necessary step toward writing the concise logic expected in professional C and C++ projects. Let's look at the correct solution. First, we declare our variables and their values. Int length equals 10 and int width equals 5. Then we declare int area and assign it the result of length times width. Next, we evaluate the result using the conditional operator. We check if area is greater than 40, question mark. If true, print big, colon. If false, print small. If your code failed to run, check the very end of your ternary statement. The compiler immediately flags an error if you omit the final semicolon. Just like a variable declaration, you must close the instruction so the compiler knows the decision is complete. This cheat sheet brings all the rules together. It shows our three core data types: the strict order of variable assignment, and the structure of the ternary operator. Take a screenshot of this for your notes. Internalizing these rules for syntax and memory is the baseline discipline required to build systems like Windows, Linux, and the embedded hardware used globally.